Hey, if you struggle with low stomach acid production, can't digest your food, you're constipated, you're definitely not going to want to miss this episode of Dr. Osborne's Zone. Stay tuned, we'll be right back. You unlock this door with the key of compassion. Beyond it is another world, a world of science, a world of common sense, a world of sanity. You're moving into a land of both empathy and ethics, of nutritional knowledge and empowerment. You've just crossed over into Dr. Osborne's Zone. Today on Dr. Osborne's Zone, a deficiency in this nutrient can contribute to skin inflammation, loss of stomach acid production, brain fog, allergy reactions, and so much more. So let's dive into histidine. Histidine is an essential amino acid, first isolated in 1896 by a Nobel Prize-winning German physician by the name of Albrecht Kossel. It's one of the 20 standard amino acids used in protein production in the body, and it's categorized as essential. Now, keep in mind, remember that essential means that your body cannot produce it, you have to eat it. And so if you don't eat enough, you suffer the consequences, so to speak. And so keeping in mind, when we talk about amino acids are derived from protein. And anytime we engage in this conversation, especially in today's age, there's a concentrated, concerted effort, especially in today's kind of nutritional dogma, about demonizing protein from animals. And so there's this big trend, and people are pushing toward plant-based proteins and cricket-based proteins and processed proteins that come from things like soy, etc. But we really want to make sure we're getting adequate histidine through real food. And so you can't leave protein out of the equation. Too many doctors have demonized it, so don't fall prey to that. And if you haven't already, check out my crash course on protein, and it'll give you a general overview of that topic so that you don't fall into a trap. Now, let's talk about histidine's functions. There's several of them. We'll do a deeper dive on it, but kind of in synopsis here, one of the core functions of histidine is the production of histamine. Now, this may be sounding familiar to many of you because histamine, commonly doctors prescribe antihistamine drugs or antihistamines, and that's to combat things like allergies, the symptoms of allergies, the watery, teary, itchy eyes, the sneezing, the coughing, the itchiness, etc. So, and we are in springtime, but you can't make histamine without histidine. And so some of you may be thinking, well, man, I'm going to take the histidine out of my diet so that I'm not as allergic. It doesn't work quite that way, and we'll get into it in a minute. Histamine is not just, though, for allergies. Histamine is a precursor to making stomach acid. It's a precursor amino neurotransmitter in your brain, so it helps your brain function. That's why when you take an antihistamine, you get sleepy and groggy. So histamine production, very key. Number two, nervous system and myelin support production. So histidine contributes to the production of the myelin sheath, which is essential for nerve protection and cognitive health. Remember, the sheath around your nerves, the insulator around your nerves, so that the electrical system of your body works properly. We know that histidine is critical for the transport of oxygen. It helps in the production of that protein called hemoglobin. You know, if you've ever gone to your doctor and done a general chemistry test, where they measured a CBC, a complete blood count. Usually hemoglobin is part of that test, and it's an indicator, sometimes if it's low, of anemia. Well, you can't make hemoglobin without histidine, very important, and so that hemoglobin carries the oxygen to all of your cells in your body, making sure you have enough of it to generate and drive energy, but it also is very important for stabilization of blood pH. The blood pH should be relatively alkaline, and so again, if you don't have adequate histidine, you can affect that tremendously. Enzyme and metal ion binding. Histidine binds certain metals. It can bind with zinc and copper. It can bind with iron, and you know it's important that it makes those binds because, like in the case of hemoglobin, it's binding with iron. But there are several proteins where histidine will bind with zinc and copper to provide certain types of antioxidant functions. As you can see here, anabolic or antioxidant rather, and metabolic enzyme function. So we need histidine for those things. We also have pH buffering. As we mentioned over here, it plays a role in pH, but its unique structure allows histidine to act as a natural acid-base buffer, especially with red blood cells, but it does this as well in muscle cells very well. One of the things that histidine helps to produce is a compound called carnosine, which is a dipeptide, and it serves as tremendous support for the muscle, not only in your skeletal muscle, but also in your heart. We know histidine is an antioxidant and an anti-inflammatory. So scavenges free radicals and binds toxic metals, helping reduce oxidative stress and inflammation. So a lot of key functions for this very important amino acid. Now, let's look at some of the research here. Let's dive a little bit deeper. So on the biochemistry of histidine, I'll blow this up for you. Again, one of the 9 essential amino acids humans must obtain from the diet. So key word there is you got to eat it. You know, you can supplement with it, but you should be looking for foods with it. And we'll talk about the foods that contain histidine shortly. Performs important anti-inflammatory, antioxidant, and anti-secretory functions in the body. Deficiencies in histidine can pose problems across various body systems: skin, kidney, blood, neuropsychiatric, and immune system dysfunction are all potential possible side effects of histidine deficiency. Essential histidine metabolic byproducts are histamine. As I mentioned earlier, you can't make histamine without histidine. Something called urocanic acid, as well as muscle dipeptides. I mentioned carnosine a moment ago as one of those. It acts as a neurotransmitter. It modulates inflammation response. It helps with gastric acid regulation. The urocanic acid that it helps to produce helps to create the skin barrier. How does your skin protect you from UV light? In part by this chemical, precursored by histidine. So histidine also has links to UV light absorption and immunosuppression. Coming down here, histidine residues are also crucial to maintaining the myelin sheath. As I mentioned earlier, histamine is released by mast cells to bind histamine receptors, and there are several different types of histamine receptors, and so lots of different functions. We'll talk about those shortly. You see the metabolic production of carnosine, which combats intramuscular acidosis, again, buffering. It maintains proper pH in the muscles, and there have been research studies showing the enhancements of exercise because of maintaining that proper pH. Okay, let's pull up some chemistry here for those of you who like to get nerdy. Here's histidine right in the center of this diagram, and what we've got here is the breakdown pathways, or the metabolic end pathways of histidine. So, you know, we get histidine through eating, so we get it through the diet, and then one of those pathways going in this direction here. There's an enzyme called histidase. We require zinc. It's a zinc is required for this thing to work, and that's how we produce this substance, urocanic acid. Now, as I just mentioned, this one's important for the skin. You can see here, since the skin lacks the enzyme to make this stuff, it's important that you have histidine. Histidine helps with the buildup of this substance in your skin, and that provides natural moisturizing factors for the skin, as well as UV absorbing compounds, ultraviolet. So it basically gives your skin natural sunscreen. And it's why it's so important to eat protein. So many people avoiding the protein and avoiding the sun. You know, the doctors are saying animal protein is bad and sunshine is bad, and here we are smathering ourselves in sunscreens that are full of carcinogens in order to protect ourselves. But the protection is built in with a great diet. We know that histidine can also form histamine. Now, this process to make histidine into histamine requires this B vitamin, vitamin B6, something called pyridoxine or pyridoxal 5-phosphate. It's very important that you have adequate B6 in your diet as well if you want to make histamine appropriately. Now, if we look at histamine, here's a table right here to the right. You see histamine receptors. There are 4 different major types of receptors for histamine, and they all have different functions. As I was saying earlier, some of you that maybe suffer from seasonal allergies are thinking, man, I need to not eat histidine so that I don't make histamine, but it doesn't quite work that way. Some of the histamine receptors actually help protect you from allergens. So we've got different ones. We've got what are called H1 receptors. These are found in the brain, in the lungs. They're also found in the smooth muscle of your blood vessels and in your lymphatic or your lymphocytes, your white blood cells. And so you can see the main function is it causes bronchoconstriction as well as vasodilation. This is what, for many people, leads to the skin rash, that urticaria, and induces wakefulness in the brain. We also have H2 receptors. These ones are found in the stomach, the gastric parietal cells. They're also found in the smooth muscle, brain, and heart. But what do they mainly do? Stimulates these gastric parietal cells to produce hydrochloric acid. Now, how many of you suffer with low stomach acid? As a matter of fact, many people that get diagnosed with gastric reflux don't have too much acid. They actually have this problem right here. They have low acid in the stomach. When you don't have enough acid and then you try to eat your food, when you're trying to eat your protein, you don't break it down. That acid's a requirement to break protein down and to break it down into smaller substrates of amino acids, etc. So when your acid levels are low, your protein doesn't digest properly, and it can actually sit in your gut, weigh your gut down, create putrefaction byproducts, which isn't good, but it can cause for a lot of people that sense of bloating after a meal, or that sense of heaviness, and ultimately can lead to severity of constipation. So we want to make sure that we can produce stomach acid, right, an adequate quantity of stomach acid, so that we can digest our protein, so that we can have regular bowel movements and avoid constipation. So what happens when you take an antihistamine to block your allergies is you're also blocking your body's ability to produce stomach acid. And this is why so many people who are allergy sufferers also have gastrointestinal problems. So it's an important note to make. If you're on those kinds of medications, understand that consequence and side effect is going to be protein maldigestion, which can lead to a host of other types of problems. Now, we also have these H2 receptors in smooth muscle, brain, and heart tissue as well. So again, if you're taking those antihistamines, it's going to potentially affect all of those. And we now have research studies that show that taking antihistamines affects the brain and increases the risk of the development of cognitive decline and dementia. So, not saying don't take your medicine if you're being prescribed. What I'm saying is you should have that conversation with your doctor about the potential for these side effects, because nobody wants to trade allergies for cognitive decline and dementia. We also have H3 receptors, exclusively found in neurons, nerves. And their job is to inhibit the release of histamine. So this is where I was saying it's not quite as simple as don't take histidine so that you don't make histamine, because this type of receptor actually helps you with allergic responses, and so you want it. So you can see it inhibits the release of histamine from histaminergic neurons, promoting healthy sleep. We have H4 receptors that are important on immune cells, mast cells, and intestinal epithelial cells, sensory neurons, as well as cancer cells, which induces what's known as chemostasis, chemotaxis, and degranulation of mast cells. So why is that important? Why do we want degranulation of these mast cells? We don't want too much. If you've heard of mast cell activation syndrome, or MCAS, a lot of people who are in mold develop hyperallergenicity. And the reason why is some mold toxins, specifically one called Zea, causes your immune cells causes your immune system to produce more mast cells, and that leads to more histamine response. And so people oftentimes in mold will have tremendous food reactions. They'll have tremendous amount of food allergy problems. They'll start collecting food allergies, and they'll become hyperallergenic to most things. But we actually need these mast cells. They're very important, because when they do degranulate, that histamine that's released serves as a part of healthy inflammation, and we need that healthy inflammation as part of how we break down damaged tissue and clear and make room for the recovery and the rebuilding of new tissue. And I talked about this recently in our show on resolvins. If you haven't watched that show on SPMs, SPMs are substrates of omega-3 fat that help to resolve inflammation or help to lead to healthy inflammation. So many of you maybe that are struggling here with excessive histamine problems and chronic inflammation, you definitely, those of you who are having that problem, want to go back and watch my crash course on SPM, because that might be something that's extremely helpful for you. But coming back to this diagram, so histidine makes histamine. There's different receptor sites or different types of receptors for histamine with multiple different types of functions. We know that also that a breakdown product of histidine, besides this urocanic acid in the skin, can actually contribute to the formation of L-glutamate, which in turn helps you make glutamine. Now, why is that important? So glutamine's not an essential amino acid, meaning you can take and you can make glutamine from histidine. Ultimately, you can get to glutamine as well. What does glutamine do? Glutamine is the primary fuel for enterocytes. Those are your small intestine cells. And so glutamine deficiency can cause leaky gut. So now we're talking about histidine playing a role indirectly through glutamine in leaky gut. But we also know that glutamine is not just the primary fuel source for enterocytes, but it's also the primary fuel source for lymphocytes. And these are specialized white blood cells that help you produce antibodies and recognize good guys from bad guys, and help your immune response work effectively. So glutamine is a very important amino acid that we can derive from histidine through this pathway of breakdown. This right here, this tetrahydrofolate, this is folate. This is vitamin B9. For those of you who, again, want to geek out on biochemistry. So histidine's fate leads to many beneficial chemicals that will help your body function properly. The other nutrients involved in helping histidine do this are zinc, vitamin B6, as well as vitamin B9 in the form of methylfolate. Keyword methylfolate. Don't take folic acid. For that, folic acid is synthetic folate, and not something I really recommend that you do. Okay, here is just kind of a larger diagram, more simple. You can see histidine through this enzyme, histidine decarboxylase, requiring vitamin B6, creates histamine. Okay, one of the other breakdown paths is that histamine, when histamine is formed, it breaks down into something called N-methylhistamine, and that requires S-adenosylmethionine, which is a methyl donor. Basically, this molecule drops off a methyl group and methylates histamine to break it down, and that's an important part of histamine degradation, so that we can recycle these amino acids. Okay, some other functions of histamine here. So these are some of the functions of the proteins that are produced as a result of histidine. And so you can see HIS, that's histidine-rich proteins or peptides. So in this case, this top box, you can see heme-containing proteins. These are your hemoglobin and your myoglobin. Myoglobin is the equivalent of hemoglobin, but it's in your muscle. And it's important for oxygen in your muscle, for that oxygen carriage in your muscle. So again, these two proteins, hemoglobin and myoglobin, responsible for carrying oxygen, and oxygen's a rate limiter for how your body is able to produce energy. We also know nitric oxide synthase. That's the chemical that helps to produce nitric oxide. Now, if you watch my crash course on arginine, we talk about how nitric oxide is made. You need histidine to convert arginine into nitric oxide because it helps to drive that enzyme. And what does arginine do? As it makes nitric oxide, this helps with blood vessel dilation. So otherwise you get stiff blood vessels that won't dilate. You can develop high blood pressure and other problems. So histidine playing a role in that. We also know there are enzymes called catalases, which are beneficial enzymes that help the body function properly. Also chemicals called cytochromes. These are very common. Cytochromes are in the liver and help with detoxification. So pretty important, histidine, in that regard. Now there's also something called a histidine-rich glycoprotein, and these are very important in regulating several processes, biologically speaking, such as coagulation, which is blood clotting, but also immunity. We know that histatins are compounds where, especially in the saliva, where histidine will bind to copper and zinc, and these different proteins have antibacterial, antifungal, and wound healing properties, and have investigated or been investigated for treatment of different oral inflammatory diseases. So these three types of proteins all require histidine. Then we get down to the histidine-rich calcium-binding proteins, which play a role in storage and release of calcium. Remember, calcium is an electrolyte, and it allows your nerves and your muscles to work properly. Histidine playing the role here, so you can see cardiac sarcoplasmic reticulum. There's a specialized type of organelle inside your heart cells. These help regulate calcium flow and regulate the rhythm of how your heart beats, so very important in that regard. And then there's a protein called filaggrin, which is in your skin barrier. And so this is what we were talking about earlier, where the formation of the natural moisturizing factor in the skin, this is a protein that helps aid in that. So histidine, lots of different functions, lots of very important functions, iterating that we want to make sure that we're getting enough of this in our diet. Let's talk about symptoms of histidine deficiency. Some of the core ones, and these are in humans, right? So anemia, especially anemia that's non-treatment responsive, meaning you're taking iron to correct the anemia and it's not working. You need histidine to help shuttle and bind iron to make hemoglobin. So if you have a non-responsive, non-treatment responsive anemia, you might consider looking and asking your doctor to measure your histidine levels. Now, one of the other non-responsive anemia issues happens with gluten, just as a side note. So gluten can cause a damage. Gluten damages the stomach lining, leading to iron malabsorption. So even though you may be being treated with iron, you're not absorbing it properly. That's just another type of iron, of iron anemia that's resisting treatment. We also know that symptoms in humans are neurological problems. We'll get into some of the human research here shortly. We know that in kids, inadequate histidine can lead to stunted growth. We know it can cause cognitive issues, as well as frequent infections because of its role in your immune system. We know that because of its buffering role with pH, it can lead to muscular fatigue and weakness. As well, we know it can contribute to hearing loss, and that has to do with neurological mechanisms and histidine's function. Okay, let's look at some of the research here. So this study, really good study on so you can see here the predicted effects of histidine administration. We know that histidine has antioxidant properties, anti-inflammatory properties, protein buffering power, a metal ion chelator, protection against glycation, which is against high blood sugar, as well as oxidation of fats in the bloodstream. We know that histidine improves erythropoiesis. What does that mean? That means this is red blood cell production. So it helps your body make red blood cells, which are critical in carrying oxygen to your tissue. We know it can reduce fatigue, increase filaggrin, that's that skin protein that helps protect your skin. And then we know it can increase THF, that's folate. Okay, this is tetrahydrofolate, so this is vitamin B9. This is what we were talking about a moment ago. The byproduct of the breakdown of histidine leads to improvements in methylation of vitamin B9. So potential benefits, high intensity exercise. So those of you that are exercising aggressively, you might want to have your histidine levels checked if you're struggling. Age-related disorders, those of you struggling cognitively or neurologically. Those of you with cataracts might want to consider having your histidine levels checked. Obesity and metabolic syndrome, we know it can have impacts on the inflammatory cascade. There have been human studies on histidine being effective in patients with rheumatoid arthritis. We know there's implication here for inflammatory bowel disease. I'll talk about why in just a minute. Cardiac surgery and organ preservation, as we mentioned, you need histidine to regulate calcium in your heart muscle. Malignancy, and this is not necessarily, those of you with cancer that maybe are taking methotrexate, what they've found is that histidine helps methotrexate work better. So not that I'm a fan of that particular medication or the traditional methods of how cancer is being treated, but again, it's information for those of you who are maybe taking that medication. We know, we can keep in mind that methotrexate blocks. This is interesting, right? A lot of overlap here, but blocks vitamin B9. It actually causes a vitamin B9 deficiency. We know histidine helps methylate B9, but we know that methotrexate can block it, but histidine helps methotrexate work better. We know that histidine deficiency can lead to skin inflammation and then, again, anemia of uremic patients as well. So let's look at a few more things here. We said that it would help to kind of help mitigate inflammatory bowel disease, and so I want to show you what some researchers found with histidine as a mechanism to fight against Candida. So if you've not heard of Candida, Candida is a type of yeast that inhabits human GI tracts, but when you get Candida that grows too strongly or you get an overgrowth, in essence, if that goes up, as yeast, what does it do? It ferments carbohydrates. And when it ferments carbs, it produces alcohol that can damage your gut. It produces alcohol that can damage your liver. And, but it also produces fungal toxins that can damage your mucosal barrier. And so what these researchers were trying to understand is what was the benefit? How did histidine, what was the mechanism of how histidine helped to reduce Candida from becoming problematic? And you see, so what they found is they found it has antimicrobial properties. There's a histidine-rich glycoprotein, which you see here, HRG, histidine-rich glycoprotein. HRG bound to Candida cells and induced breaks in the cell walls of the organism. So that histidine-rich protein basically pulled apart or broke apart the membrane, the cell membrane around Candida cells, killing them, making it harder for them to thrive and survive. You see, correspondingly, HRG preferentially lysed ergosterol. This is the cholesterol equivalent for yeast. Yeast use ergosterol as a major source of fat. Humans use cholesterol, but you can see it lysed it or it cut ergosterol, making it less available for yeast to have. HRG, okay, so you can see here, both antifungal and membrane rupturing activities of HRG were enhanced at low pH and mapped to the histidine-rich region of the protein. So at any rate, this study was carried out in mice. We can't, sometimes we can't just directly translate animal studies to human studies, but I think it's a very interesting finding. And a lot of times we do see that what happens in animals also happens in humans once the research is performed. But I would just say, if you are having trouble with, ladies, if you're having trouble with chronic Candida overgrowth or vaginal yeast infections or those types of problems and nothing's working, you might just ask your doctor to measure your histidine. You see in this study, anti-inflammatory and anti-secretory potential of histidine. This is another mouse study, but this was against salmonella. So here I was telling you earlier about inflammatory bowel disease and histidine having potential benefit. Again, you can have inflammatory bowel disease caused by Candida. You can also have inflammatory bowel disease problems caused by bacteria like salmonella. So you see here in this mouse study, histidine, a known antioxidant, reduced the amount of fluid accumulating in the intestinal lumen and protected the intestinal tissue from the damage of salmonella. And further evidence favoring this mechanism included the capacity of L-histidine to scavenge reactive oxygen species produced as a result of LPS. What is LPS? So when you have these bad bacteria, one of the things they produce is something called an endotoxin. And one of the primary endotoxins is called LPS, lipopolysaccharides. And these guys can cause microscopic damage to the gut wall, to the gut lining, creating leakiness, right? So leaky gut, and that can create a cascade, a whole host of different problems, because once you have LPS damaging the gut, they can now leak into your portal circulation, which goes straight to your liver, and these have now been linked to fatty liver disease and liver damage, as well as systemic inflammation. So just because you have bacteria or bug in your gut doesn't mean it can't translate across into the system, to your blood, creating system-wide inflammatory process. So again, this study, histidine was effective at reducing the damage caused by these endotoxins produced by bacteria, the LPS endotoxin. So the potential therapeutic value of anti-inflammatory drugs containing an L-histidine-like structure could protect infected mucosal tissues irrespective of the etiology or the source of the microorganism. So animal studies give us great insight. Those are animal studies. Okay, let's move on to human. So human studies have shown histidine benefits the following: metabolic syndrome, obesity, chronic inflammation, poor stomach acid production, mental fatigue, cognitive issues, dialysis patients benefit, and patients with dermatitis, atopic dermatitis benefit. Let's break that down and show you some of the research on this. And more than that, like this first study's on COPD. So this was a trial done, published in International Journal of Chronic Obstructive Pulmonary Disease. In our COPD cohort, meaning this is chronic obstructive pulmonary disease, okay, so this is asthma, bronchitis, etc. Serum histidine was reduced with an associated increase in histamine and basophils, which means more mast cells and more histamine production. Histidine is known to be inversely associated with inflammation and oxidative stress in patients with metabolic syndrome and chronic kidney disease. In fact, histidine supplementation has been shown to suppress inflammatory processes. We found the same relationship in our cohort, as histidine was negatively correlated with interleukin-6 and TNF-alpha. What are those? Those are chemicals that scientists and doctors use to measure inflammation. So when these are high, they're markers for inflammation. So implying the possibility that lower histidine concentrations may contribute to pro-inflammatory state in patients with COPD. So there you have it. There's lung inflammation in histidine. Here's another study on histidine levels as indicators, as predictive indicators of disease activity in a condition called Takayasu arteritis. Now, this is an autoimmune inflammation of the arteries, and it can be very, very problematic for people suffering with it. So histidine levels were significantly decreased in active Takayasu arteritis patients. The conclusion of this study demonstrated that altered circulatory histidine levels in TA patients that may serve as a surrogate marker for improving the diagnostic screening of active and inactive patients. So they're actually studying histidine because it's known to reduce inflammatory chemicals like interleukin-6 and TNF-alpha as an indicator for the therapeutic situation around people with that disease, whether their disease is active or not. In this one, rheumatoid arthritis was treated with L-histidine. This was a double-blind, randomized, placebo-controlled trial. And so you can see what they were using was L-histidine to treat patients, and they were using 4.5 grams per day, or they were using placebo. And they did this for 30 weeks. And what did they find? They found a decrease in rheumatoid factor. So rheumatoid factor, RF, is the primary lab marker for rheumatoid arthritis. And so they found a reduction in that lab marker in patients supplementing with histidine. There was also suggestive evidence of a beneficial effect of histidine in patients with more active and more prolonged disease. So I'd love to see follow-up research being done on this, because one of the problems, as we know, with nutritional research is it's hard to fund, it's hard to get funding, because you can't patent L-histidine. L-histidine is an amino acid. It's God's work, and there's no way to patent it. So there's not a lot of money. There's not a lot of money scientifically being thrown at nutrition as an investigatory for disease outcomes. And so we have limited studies as a result of the lack of financial incentive. Now here's another study. You can see histidine supplementation improves insulin resistance through suppressed inflammation in overweight or obese women with metabolic syndrome. And so this was a randomized controlled trial where they, it was also double-blinded, where they gave 4 grams a day of histidine. So you can see here 4 grams a day. The N was 50, so this was 50 patients were being studied. Or they gave an identical placebo, and this was for 12 weeks. So 4 grams a day for 12 weeks. And here's what they found. Histidine supplementation significantly decreased something called HOMA-IR, which is a measure of insulin resistance. So it improved these patients' insulin response. We know that it lowered their waist circumference, on average of 2.86 centimeters. We know that it lowered fat mass by 2.71 kilograms. We know it reduced serum inflammatory cytokines TNF-alpha by almost 4 points. We know it reduced oxidative stress as measured through superoxide dismutase and glutathione peroxidase by almost 18 and almost 14 points, respectively. The conclusion, histidine supplementation could improve insulin resistance, reduce BMI, body mass index, reduce fat mass, and non-esterified fatty acids, NEFA, that's what that stands for, and could suppress inflammation and oxidative stress in obese women. So fantastic outcomes. I mean, this is drug-like impact, right? So with a nutrient, with just simply adequate diet, possibly, but also supplementation. 4 grams of histidine led to this effect. So here's another study in humans on cognitive performance in subjects with high fatigue and sleep disruption scores. And so they gave 1.65 grams a day to these patients. And this was a double-blind placebo-controlled trial as well as 20 subjects with high fatigue and sleep problems. And the results suggest that daily ingestion of histidine may ameliorate feelings of fatigue, increase performance during working memory tasks, and improve the clear thinking and attentiveness of these patients. So cognitive performance enhancement. Here's another study. You can see in kidney disease patients, plasma histidine concentrations were significantly lower in patients with chronic kidney disease. Plasma histidine was negatively associated with age, C-reactive protein, interleukin-6, leukocytes, thrombocytes, fibrinogen, hepatocyte, growth factor, as well as adhesion molecules, insulin-like growth factor, and 8-hydroxy-2-deoxyguanosine. What does all that mean? That means that basically low histidine was linked to worsening of all these other things. And so all these markers here are markers of inflammation or markers of metabolic chronicity. 8-hydroxy-2-deoxyguanosine is a metabolic byproduct of DNA damage. And so it's saying that low histidine increased the amount of this chemical that they were finding in patients. It also was associated with poor hand grip strength, lower hemoglobin, and lower albumin. And yet again, we've talked about the hemoglobin aspect. Albumin is a serum protein that's important for delivery and carriage of nutrients through the bloodstream. We also know it was associated with all-cause mortality. So low histidine increased risk of death, basically. Low plasma concentrations of histidine are associated with protein energy wasting, inflammation, oxidative stress, and greater mortality in chronic kidney disease patients. So how many of you with chronic kidney disease have ever had your doctor measure your histidine? Chime in the comments. I bet the answer is 0. We test histidine on everyone that walks through the door. I probably see histidine deficiency in anywhere from 10 to 15% of the people that we measure it in. So it's not an uncommon deficiency. Protective role of histidine supplements against oxidative stress, damage in the management of anemia and chronic kidney disease. So another kidney disease study, you can see histidine is essential in globin synthesis and erythropoiesis, which is red blood cell formation. It's been implicated in the enhancement of iron absorption from human diets, so it aids iron absorption. Studies have found that L-histidine exhibit antioxidant capabilities such as scavenging free radicals and chelating divalent metal ions, hence the advocacy for its use in improving oxidative stress in chronic kidney disease. Okay, we talked about this a few times, but this was actually, again, human study. So this was a randomized, double-blind, placebo-controlled crossover nutritional supplementation pilot study where they were giving histidine in adult atopic dermatitis patients. There's 24 people in this study. And you can see once daily oral histidine significantly reduced atopic dermatitis disease severity by 34%. That's more than a third reduction using a physician assessment scoring tool. And so we have, I mean, that's quite significant when you consider that it's an amino acid. It is a low cost to humans and a low side effect profile, virtually at these doses, a no side effect profile. And so this was just a 4-week study, and you can see 39% patient self-assessment using the patient-oriented eczema measure tool. So they used 2 different types of measuring tools. One of them was a 34% increase, the other almost a 40% improvement. Summary: the clinical effect of oral L-histidine in atopic dermatitis was similar to that of mid-potency topical corticosteroids. Think about that for a minute. That's a very powerful statement. Taking L-histidine, this simple amino acid, was as effective as corticosteroid use. Now, why is that such an important takeaway? Because if you're stuck on corticosteroids, if you're using topical application of this class of medication over long periods of time, one of the common side effects is increases in blood sugar, increases in blood pressure. We know that corticosteroids reduce vitamin C, which is critical for maintaining skin integrity. So over time, the longer you're on it, the worse potential for your skin because you're blocking and inhibiting vitamin C. We know they reduce vitamin D, which is important for inflammation. We know corticosteroids affect calcium, lower it, and they reduce magnesium, and they reduce zinc. So we don't want all these side effects. These are horrible nutritional side effects. We also know that long-term corticosteroid use can cause scalding skin syndrome because you actually become addicted to the corticosteroid. If you quit using it, your skin dramatically worsens and creates a scalding skin-like reaction. If you look through some of my older videos, I had years ago a patient testimonial where is a woman that was basically being overprescribed corticosteroids for years and years and years to treat her polymyalgia, which is a form of muscular autoimmune disease, and it ended up causing severe facial outbreaks and rashes, and she ended up developing this problem right here as a result of chronic corticosteroid use. And it took us more than 12 months really to get it under control. But you know, part of how we did that was diet change and nutrition supplementation and nutritional testing. But bottom line is this study for atopic dermatitis shows that histidine was equally effective as mid-potency topical corticosteroids, and combined with its safety profile suggests that it may be a safe non-steroidal approach suitable for long-term use in skin conditions that are associated with filaggrin deficits. Remember, filagrin's that protein that histidine helps to produce. Now, here's another report here on histidine supplementation in adults and children with atopic dermatitis. The inflammatory skin condition is prevalent in 20% of young children. That's a lot. There's an unmet clinical need. We have definitely an unmet clinical need. Kids being pumped full of steroids is not winning this war, but unmet clinical need. What do we do with these kids? They're 20% are having inflammatory skin conditions. So unmet clinical need for safe interventions that target the etiology of the disease. Deficiencies in the skin barrier protein filaggrin have been identified as major predisposing factors in atopic disease in mammals. L-histidine is rapidly incorporated into epidermal filaggrin, and subsequent filaggrin proteolysis releases L-histidine as an important natural moisturizing factor. Again, moisturizing that skin that's drying out and inflamed. It has therefore been hypothesized that L-histidine supplementation will be a safe approach to augment both filaggrin and NMF, the moisturizing factor, and enhance skin barrier function and reduce the severity of atopic dermatitis. In this clinical pilot study, adult subjects who took a placebo or they were using 4 grams of L-histidine daily, this was an 8-week study, L-histidine reduced the symptoms by 34%. Tremendous outcome. You see another one here in 98 adults, 4 grams of L-histidine daily reiterated a lack of causal AEs, skin inflammation, and also reported 33% reduction in topical corticosteroid use. And another one, a placebo-controlled clinical pilot study conducted in young children with atopic dermatitis, taking 0.8 grams. So these were 3.5-year-old kids. So if you've got a kid, small kid, 0.8 grams of L-histidine a day, showed that eczema area and severity index scores were reduced by almost 50%, 49% reduction. These studies indicate that the levels reported oral L-histidine supplementation is well tolerated and has potential has potential as a safe intervention for long-term use in the management of atopic dermatitis. Now, those of you who've listened to me for any length of time know I'm not about managing. I don't want people to have to manage their condition. Whether you're managing it with a corticosteroid or you're managing it with histidine, I'd rather you manage it with histidine if it's working for you, because there's no side effect profile from that, unlike the side effects of a corticosteroid. But at the end of the day, you also want to know what is driving the skin inflammation in the first place. And so I know this isn't a show about gluten, but those of you watching to learn about histidine should know that the vast majority of skin inflammation of unknown origin responds extremely well to gluten-free diets. And so if you have not entertained this, if this is new news to you, you need to go and pick up a copy of No Grain, No Pain from your library, or you can pick it up at Amazon if you want to own your own copy. But this is my book. I wrote this book years ago. This is the diet plan to reduce chronic inflammation. And again, this type of diet has tremendous impact on folks that have chronic skin inflammation and even other forms of inflammation, chronic joint inflammation, chronic nerve inflammation, chronic inflammation systemically in the body. So take advantage of that book and that diet if that's new to you. And in the meantime, consider asking your doctor about histidine and supplementing with it. Okay, let's talk about lab testing. Keep talking about testing, right? The credo here is test, don't guess. Now, a lot of doctors will tell you, we don't need to do that. Histidine's not important. And what they're really saying is, I don't understand histidine. I don't know what histidine is. I don't even really know how to test for it. So I'm going to dismiss it as a lack of importance. That doesn't make them right. You know, if you want to change the world of healthcare, you've got to demand more from the healthcare professionals. And the lack of nutritional knowledge in the average doctor is appalling, and it's not acceptable. And you need to get into the room with those doctors and have these conversations, and you need to push. Because the more of you that do it, the more of you that lean into your doctor about getting educated about nutrition, hopefully the more doctors are going to do it. And then we're going to have a better health system as a result of that pressure. But you have to put the pressure on the doctor. Test, don't guess. Now, plasma levels, I'm even giving you, you can measure this stuff in the plasma. Insurance should cover this type of test. But these are reference ranges. 47.2 to 98.5 micromoles per liter is normal in terms of plasma levels of L-histidine. And then there's another way to measure it too, and that's called INA, intracellular nutrition or nutrient analysis. And this is a measure of functionality. This is an outcomes-based test where we look at cell growth and whether or not the cell growth is enhanced or improved as a result of a nutrient addition to the cell. So in this case, histidine would be added to your cell, and if your cell functionality improved, we actually can measure that, and that would be an indicator that giving supplemental histidine would be effective for cellular health in those individuals. So you can ask for either one of these two types of tests. If your doctor looks at you like you've got horns coming out of your head, go to Gluten-Free Society. This is ourhub.org, glutenfreesociety.org, and there's a lab tab at the top of the page, and you'll see and you can read more about INA testing. Get armed with the knowledge, and if you don't have doctors that will run it, you can pick one up there, and you can get it done yourself, and it measures your histidine among 54 other nutrients that it measures. So if you really want to get a good feel for your nutrition status and what you might need, again, going back to test, don't guess, that's the best way to go about it in a comprehensive fashion. Okay, let's talk about supplementation and requirements of histidine. So, giving you some numbers here, and these are estimations. The estimated daily requirements in infants 0 to 6 months is 28 milligrams per kilogram per day. We're talking about, again, L-histidine. And for adults, it's 10 milligrams per kilogram per day. Notice it's higher in infants than it is in adults, and that's because infants are growing. And when we're growing, we need more protein, and we need more amino acids. Now, there are factors that increase the need for histidine. Certainly, as I mentioned, growth, both in children, infants, and adolescents, but also pregnancy. Women, ladies, if you're pregnant with kids, one of the best things that you can do is get your nutrition status checked, because pregnancy is a tremendous demand on nutrition, and lactation as well. Those of you, ladies that are breastfeeding your children, I've seen the worst in my career of several decades. The worst deficiencies I see are in women who have back-to-back pregnancies or women who are breastfeeding. The babies just demand so much on the nutrition, and if the mom's not keeping up with that demand in her diet, deficiencies set in, and so baby doesn't pay as much as the mom pays. So if you want to stay as healthy as you can through a pregnancy and lactation, you really consider checking and monitoring that nutrition. We know that people with chronic illness and inflammation have low histidine and may have higher requirement levels, and we know people that are on hemodialysis or have renal failure. So if you're on dialysis, as I showed you earlier, people with chronic kidney disease, they get improvements by supplementing histidine. So talk to your doctor about it. You can see here, so this was published in a recent review on histidine, and they're talking about the upper tolerance level of histidine, like how much can you take as a human before symptoms can really start to set in. And so what they determined in the known and available literature on the topic is that 8 grams of histidine per day was what's called the no observed adverse effect level, or NOAEL, no observed adverse effect level. 8 grams a day. That's a lot. Most of the studies we talked about today on humans were 4 grams or less. Like in the skin studies, we said 4 grams a day improves symptoms almost 50% in some people. So 8 grams is the heightened level where you could take and not have observable adverse effects as far as the current literature is concerned. While the 12-gram histidine per day dose was the lowest observed adverse effect level, meaning that at 12 grams they started to see side effects. What was the side effect? It was in a lab test. It wasn't a patient saying, I feel bad. It was a lab test saying there's a reduction in the protein ferritin. And at 16 grams a day, there was a slightly elevated liver enzyme observation that occurred. So it wasn't patients coming back and saying how awful they felt. These were lab tests that were indicating these are potential possible side effects of too much histidine. So 12 grams a day is the lowest. 8 grams a day, no observable adverse events. So if you're considering supplementation, keep those things in mind. This was a good paper. It was a commentary written in BMJ Open Heart Journal. And I just highlighted a little section here. The clinical relevance of these findings is further suggested by evidence that use of prescription antihistamines or antipsychotic drugs that also inhibit histamine 1 receptors is associated with an increased risk for obesity. Basically, just calling back the attention that we were talking about earlier. If you're using antihistamines or drugs that block histamine, the potential implication of what that means. And in this case, all those benefits of histidine in the production of histamine. And if you're blocking that histamine, there's an increased associated risk for obesity. And these authors pointed that out very eloquently in this paper. Okay, let's talk about additional kind of concerns, potentially possible side effects if you're considering supplementation with histidine. So there's a condition called histidinemia, which is a rare inborn error of metabolism. It's not common. It's where the enzyme that breaks histamine down, or histidine down is deficient, and it results in high histidine levels, which can lead to potential developmental delay, speech issues, or learning disabilities. This is a genetic inborn error of metabolism. It's found in babies. If you're an adult watching this, you don't have this problem. I mean, the likelihood that you have that problem is almost 0%. So high histamine production. We haven't seen any studies that show that taking histidine leads to more histamine production and the consequent side effects of too much histamine, as in mast cell disorders. However, let's just approach this with common sense. If you have mast cell activation syndrome or a mast cell disorder and you're considering using histidine, proceed with caution. Look, monitor your symptoms and monitor yourself. Like I said, there's no research that shows this is a problem, but it's always good to approach something, especially if you're considering higher doses, with a lick of sense, so to speak. Imbalance with other amino acids. Now, one of the other potential side effects is if you're getting into the high doses, that 8 gram plus a day, it can disrupt the balance of your branched chain amino acids. BCAs, branched chain amino acids, are very critical, very important for neurotransmitter production and muscle integrity and repairing and healing after workouts and after exercise. So if you're on those higher doses, and this is true of anything, if you're on a higher dose of any kind of nutrient, you should be monitoring your nutritional levels with a professional. You should be working with somebody to help you navigate that. But with histidine, there is a potential that it could disrupt BCA, branched chain amino acids. So just be aware. Let's talk about food. How can we eat more histidine? Because you don't all necessarily need to supplement. I'd say those of you that have been on, a diet that has been largely plant-based, and maybe you're having some of these symptoms that we went through today. Maybe you're having some of these side effects because you haven't been getting enough histidine in your diet. There are plant-based sources of histidine, legumes, especially tofu, but lentils, chickpeas, and tofu, nuts, and seeds contain reasonable amounts of histidine. But animals are definitely higher and much more abundant in histidine. So if you've got that history and you've been on a largely vegan or plant-based diet and you're struggling with a lot of these symptoms, you might want to consider this. And whether or not you're avoiding meat, I'll leave that to you. But get your levels checked, and then supplement accordingly or increase your consumption of foods accordingly. But animal foods are very rich in histidine. Select plant-based foods have some histidine in them, but I would argue that there's a greater risk for sure in those that are following a plant-based diet for not getting adequate histidine, especially when you start things like aggressive exercise, where the need might increase. As we said earlier, there are certain people that need more histidine. Chronic inflammation, people that are exercising, athletes, are going to need more than the average person. So if you're on that plant-based diet and you're increasing your activity or you're chronically inflamed, the risk is even greater. So just get yourself checked. It's really easy to do. You can ask your doctor to run a plasma histidine test. It's more accurate to check INA, intracellular nutrient analysis, but look, some data is better than zero data, and if your doctor will run it for you, great, you'll have the information and you can take and make adjustments in your diet or in your supplementation accordingly. So there you have it, the breakdown on histidine. Look, I hope you enjoyed the show. If you did and you found value from it, I'd appreciate a like down below and hit that subscribe button if you find this content helpful and you want to check out more of my crash courses. We have an entire section, hundreds of crash courses on a variety of different vitamins, minerals, amino acids, fats, and other nutritionally related topics. I would encourage you to explore our menu. We have so much information, it's overwhelming, and I think that you could benefit tremendously by checking it out. Also, come visit me at Gluten-Free Society. If you haven't already, if you're struggling with chronic inflammation or autoimmunity, we have a ton of free resources there at Gluten-Free Society. All you have to do is sign up there for our newsletter, and we'll send you a ton of free information to help you navigate diet, lifestyle change, and overcome chronic inflammation. Thanks so much for tuning in. We'll see you Thursday at 12:30 Central Standard Time for a live Q&A as we do every week. Thanks for tuning in to the Dr. Osborne Zone. Don't forget to share, like, and subscribe for more content like this, and make sure you come back next Tuesday at 6 p.m. Central Standard Time and Thursday at noon 30 for more episodes.